worries. All right, so we're going to section 2.4, and it's an introduction to problem solving. Now, usually, traditionally, this is my students' least favorite part because we're combining English with math. Oh no, I know, but it's part of math, is part of reading and solving problems. So that's where we are. So we're going to work on solving direct translation problems. Okay. These are your key phrases for knowing what to do in a word problem. So your key phrases for addition are sum, plus, added to, more than, increased by, total. If I read those in a problem, those things are telling me to add. Go ahead and add, right? Subtraction, we have difference of, minus, subtracted from, less than, decreased by, and less. Those are keywords to subtract. Multiplication, if we read product, times, multiply, twice, of, any of those words, they're also keywords. They're all keywords to multiply. And then last, we have, not last, next we have division, quotient, divide, into, ratio, divided by, and then equal sign. So when do I know to use an equal sign? Equals, gives, is, was, should be, yield, amounts to, represents, is the same as. Do any of these words surprise you to mean things mathematically? Yields, to result in it, to produce. Yeah, yields is a way of saying produce. Do they kind of make sense to be math related? A little bit, hopefully. All right. Oops, not the pen, not the thing. So, what do we do when we're problem solving? There are 4 things that we do. Number 1, understand. You want to understand the information that is being presented to you, okay? Number 2, translate. So you're going to go from English to math. So you're going to translate. I know how some of you already think math is a foreign language, so we're going to treat it like one. And then 3, you solve the equation that you create. And then 4, you interpret. So you should never just write 4. For what? Is it 4 books? Is it $4? Is it 4 Santas? What is it? You should always interpret your result to mean something. Okay? So again, 4 main strategies: understand, translate, solve, and interpret. Any questions so far? Okay? Let's put our problem solving hat on. So we have twice the number plus 3 is the same as the number minus 6. So we're going to break this down. So I have twice the number. So if I read twice, what do you think that means? So twice, so that's 2. Again, bear with me. That's 2. A number, do I know what it is? No. So what do I use to show an unknown? X. We talked about this. We use X. So we have 2x plus 3. Literally means plus 3. There's no secret. Plus 3 is the same as. Perfect. Equal to. The number minus 6. So again, the number is what? So now I translate it from words into math. And then now I'm able to solve. So now I can solve for x. So this goes back to us using our steps to solve. So using our steps to solve, I'm going to go ahead and draw an equal sign just to try to line down my equal sign. Try to keep it balanced. Anyone remembers, what are our steps to solve? Step 1.
Put your things together.
I got to get your x's together, right? So I need to move my x's to one side. So what I suggest is always moving your smallest x. So if I have 2x and 1x, which one am I moving? The 1x. So it's a positive. So when I move it, it's going to become a negative. What I do to one side, I'm going to do to the. It cancels out, and I'm left with x plus 3 equals negative 6. All right, x is almost by itself. Woohoo! Last step. I have plus 3, so how do I move the plus 3? Subtract. Inverse operation. I'm going to add 3. To get rid of it, I'm going to subtract. Perfect. So x equals -9. Bless you.
Thank you.
Questions about translating from English to math? Hey,
So, like when it said x plus 3 minus 6, how come we didn't do the minus 6? Because the 3 had to cancel out, right?
yes, because our goal is to get x by itself. So what's happening if our goal is to get x by itself, we really just, our only concern is getting that x by itself. We're not concerned with the things that are already alone. So we're moving away from x. You're trying to move away from x so that x can be happy and its own by its lone self. I've referred to x as the boy in the bubble. You know, he wants to be alone in his bubble, so you move away from me. Okay. Questions so far?
So when you got 2x and you took, minus x, how come you just have x there?
If it helps you aesthetically, you can write a 1. Remember that 1 is our invisibility cloakware, so it can appear and disappear when it doesn't need to be there. So technically, this is a 1 here, right? So this is 1, 1, 1, and 2 minus 1 is 1x. If you need to see it, visually see that 1, put it there. But 1 has an invisibility cloak. It only comes out when it wants to be seen and used. Any other questions about example 1? Cool? Perfect. All right, so example 2. Let's get a little more words in there. So it says the product of twice the number and 3 is the same as the difference of 5 times the number and 3/4. What? Find the number. Okay, keyword here is product. That's supposed to be a highlighter. Product. What does product mean? Multiply. So product means that we are multiplying. Now, remember how we said we want to avoid using the x? So instead of using the x, what should we write for multiplication? I can put parentheses, okay? Okay, I can put parentheses, I can use the multiplication dot, but we want to avoid using x, got it? Even if you make it tiny, it still can throw you off. All right, so the product of twice the number and 3, so we have twice a number and 3. So that shows that it's product because this is 2x times 3. Can we see that? So that produces my product is the same as, and what does the same as mean? Equals, perfect. So the same as means equals. So it equals the difference of 5 times the number and 3/4. So the difference means I'm doing what? What operation? Subtraction. Good job. So I'm subtracting something. I'm subtracting 5 times the number. So 5 times the number minus 3/4. All right. So now we have a very lengthy problem there. So there's a couple of ways to approach it. If you are really good with adding and subtracting fractions, you can solve it as such. If you are not really good with adding and subtracting fractions, you can get rid of the fraction. Okay. If you watch my handy dandy video, it tells you how to do that too, but we'll do it now. So in order to get rid of the fraction, you are going to multiply, if it's the only fraction, so notice how 4 is the only denominator we have, right? Agreed? If you want to get rid of the fraction, you would multiply every term by that denominator. So this is a term, this is a term, and this is a term. Agreed? Remember that? Terms are numbers, a combination of numbers and letters. Okay? So I would multiply every term by 4. So I would say, okay, I'm going to multiply u by 4. I'm going to multiply u by, uh-oh. And I'm going to multiply u by 4. The reason for this is to use our identity, our multiplication identity, which one is on? Inverse identity, okay? So our inverse identity is saying that, our identity property, I'm sorry. If I take 4 and times it by 1/4, it'll make it equal to 1. Do y'all remember that property we learned in 1.8? Or I think it was 1.8. So I just multiply. 4 times 2 is? 8 times 3 is? So on this side I have 20. Oh, that's ugly. These videos are going to be full of commentary. 24x equals, and then what's 5 times 4? And then the goal here, this cancels out the 4 in the denominator, so I'm just left with 3. So now I went from having a fraction problem to having a non-fraction problem. And now I just solve it as such. So my goal is to get x by itself, which is my smallest x, 20 or 24. It's not a trick question, I promise. 20. 20 is my smallest x. So if I have a positive 20, how do I move a positive 20? I subtract it. So I'm going to subtract 20x. What I do to one side, I do to the, and I get 4x equals -3. All right, is the boy in the bubble by himself yet? Nope. So if I'm multiplying by 4x, what is the opposite operation? Divide. So I'm going to divide both sides by 4. So my answer comes out to be x equals -3 divided by 4. Yes.
Why do we divide?
Because right here, where we have 4 times x, remember you're always trying to do this opposite operation. So the opposite of multiplication is division. So essentially you are multiplying by 1/4, and we're using our property that allows us to cancel out. Because 4 divided by 4 is what? 1. And so it becomes invisible and it goes away. But we have to, what we do to one side, we have to do to the other. So we have to maintain that balance. Or our scales will be offset and no one will be happy and blah, 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 blah. Okay? So that again is one way of solving it. The other way, so I'm going to erase this.
Wait.
Oh. Okay. I have, I'm sorry, I have no clue how to adjust that little box. Okay?
This have to be on Blackboard too, right?
You're pulling this off of MathLab, right?
The problems, the examples, yeah, I'm trying this is from Blackboard. These are on your Blackboard, under your content on Blackboard. That's where your notes are. Okay, so clearing. I don't know. I'll just erase. Is it erasing? Oh, do y'all see it going away? Okay, good. I thought it was like a button I could just press real quick. I was tricked. I know you're probably like, why is she using the napkin? Okay, so the other way, so initially we had 2x times 3 equals 5x minus 3/4. So the other option of solving this is to go through our steps. So step 1 is to simplify both sides. So I would clean up the left side, and 2 times 3 is?
6.
Bring down my right side because I didn't have to affect it. Okay, I'm going to move my smallest variable. So I'm going to subtract 5x. That gives me x equals negative 3/4. This was the other option. Now, the reason why this one works out so smoothly is because how many fractions do I have in my problem? 1. Okay? The other option works all the time, even if you have multiple. What do you call it? I'm sorry. You gotta hold it down and open it. All right, so this works way better and way faster, but I wanted to show you the longer method so that if I do have more than one fraction, I know how to navigate around it. Because my goal is to get rid of the fraction in the beginning if it's too much for me to deal with, okay? Okay, if it's too much for me to deal with, go ahead and get rid of it. But I want to challenge you to try to work through the problem with the fraction. I know some of y'all are anti-fraction people, but they're really not that bad. I promise. They're not. Okay? Look how much easier it was when we just accepted the fraction for who it was. Got it? All right. So our next objective is solving problems involving relationships among unknown quantities. This is where we get to those real world problems. Okay? So a car rental agency advertised renting a Buick Century for $24.95 per day and 29 cents per mile. If you rent this car for 2 days, how many whole miles can you drive on a $100 budget? So let's pause for a moment. I want you to think about if this was you for real and you were trying to budget how much it's going to cost you to rent this car. And how far you can go on your $100 budget. All you got is $100, but you really need this car for a few days. How many miles can you go? So what would you do to solve this in the real world?
I would add up the days first.
Okay.
And
So you're
whatever
gonna.
whatever I have left, I divide by 29.
Okay. So you have 2 days, right?
Right.
So you're gonna be charged for those first, right?
Which would be like $50.
Okay. So let's write out what you said. So you said I would, total up my days. Agreed? Is that what you said?
So you would really multiply that at 24.95 times 2.
Perfect.
And then subtract the 100. Yeah, subtract that number from the 100.
Okay. I like where you're going with this. So step 1, I'm going to figure out how much it's going to cost me for those 2 days, right? Because I'm going to have to pay that regardless. So if I'm renting it for days, I'm going to pay the $24.95 times 2. So what is $24.95 times 2, my friend?
49.
49.90.
Yeah, 49.90.
So I know that it's going to cost me $49.90, right? Up front. So out of my $100 budget, I'm already going to have to spend $49.90. Does that make sense? So out of my $100 budget, I might as well subtract that $49.90. When I subtract that, how much am I left with?
51.
51.10?
49.10.
51.
What?
51.
What about just 50?
Then you can go 170.
What about just 50.10? Because if I take 50 and add 49, that makes 99, and then 90 plus 10 makes 100, right? Okay, 50.10. There we go. I knew we were going to get there. So now I have $50.10 to spend on mileage. Agree? So I have price per mileage is 29 cents per mile equals 50. Good job. What do? I want to get n by itself. So mathematically, I am doing what?
Divide.
Dividing. So I would divide by 29 cents. I promise y'all, this is the hardest kind of writing I've ever done. Can y'all see my 29 cents? So in my calculator, I would write 50 and 10 cents divided by 29 cents. And I get how many miles? Did you do it? Did you try? Is he right or is he wrong?
179.
Is it exactly 179?
Nah, it's
I
like
thought
It's not
179.7.
170.
179.7.
179, and what'd you get?
I don't know.
172.7.
There we go. I was like, you keep saying it, but not what I want to hear. So you can't see the little calculator. I forgot. I'm on this computer. Okay. So on your calculator that you have, you can type that in, right? If you're getting the little calculator you're allowed, you can type that in. And all I want you to do is 172 point, what is it? So 172.7 miles. So I can drive to Austin, come back, go get something to eat, and take the car back. That says 172. We're going to all agree that it says 172. I'm going to order a fancy pen to make this work so I can be those YouTube people who write pretty. All right. Questions about real world problems. You do them all the time. You just don't think of it as a math problem, but it is a math problem. How do you feel about it? Okay, now, I could have approached it from a math standpoint and made you set up an equation, right? And said, okay, what is your unknown? What do you know? Let's write a full equation. But I wanted you to do it as if you were this person. Because I feel like you relate better if you see it in those parts as if you were working it out on your own scratch paper that you found in your purse while standing at Expedia. No, not Expedia. What is it called? What is that? Carbon Enterprise. Okay? What would you actually do? Okay? Next, let's try another one. Now this one is not real world. It's more of a geometry problem. It says the measure of the second angle of a triangle is twice the measure of the smallest angle. The measure of the third angle of a triangle is 3 times the measure of the smallest angle. Find the measures of the angles. Anytime it's talking about an object, draw the object. So anytime a problem is talking about the object, draw it. Give yourself a visual. I feel like I made it. So draw it. So I would draw me a triangle. I knew it was going to be difficult for me to draw a triangle, so I put it on here. So I knew it was getting hard, so I cheated. You see how hard it is for me to write? I'm not even drawing a triangle. So I have my triangle, and it says that the measure of the second angle of a triangle is twice the measure of the smallest. So this one is my smallest, right? So I put X. And then my second smallest is twice this next angle. And then the measure of the third angle is 3 times bigger than my smallest. So I literally identify my smallest, my medium, and my large.
That's the answer to the question.
That's your setup to it. Okay. What this requires you is to kind of do some thinking. Does anyone remember what the angles of a triangle have to add up to? 180 degrees. Good job. So all of these angles have to equal 180. All of your angles have to add up to 180. So I know that X,
A right angle is 90 degrees.
a right angle is 90 degrees. We don't know if any of these are right angles. You can't make that assumption.
No, we were just trying to recall from the elementary.
Oh, cool. Yeah. A right angle is 90 degrees. An acute angle is less than 90, and an obtuse is greater than 90. All right. So now I've set up my problem, right? All right. Now I just got to solve for X. How do I solve for x? Step 1, simplify. Can I combine all of these terms or no?
Yes.
Yes, because they all have the exact same variable. Agree?
So
So
there's 6 x's.
there are 6 x's. Perfect. So I have 6x equals 180. And then how do I figure out what x is?
It's 30.
How? What'd you do? Tell me. Don't just tell me the answer.
Divide.
I'm going to divide by 6x, right? Because this is 6 times x, and the opposite of multiplication is division.
Well, I divided like 6 into 18 and add the 0.
Perfect. That's what I want you to do. So I get x equals 30. So if I know my little angle, can I find my big angles? Excuse me, guys. So I know that I have a small, a medium, and a large. My small angle is x, and what do we get x is?
30.
So my smallest angle is 30 degrees. Medium is going to be,
60.
since it's twice the, and then my large is going to be what? 90. Ha, look at that. It was a right triangle. Surprise. I promise you I'm writing a 9 with all my heart. And it's just, I'm going to go Amazon. Perfect pens to write on computers with. And I'll come back with one with Prime. It'll be here in 2 days.
Why is X over there?
Oh. I just didn't put enough space in between them.
Oh, okay.
There we go. So I simplified. So x equals 180 divided by 6, right? And what is 180 divided by 6? 30. So x equals 30. And now that I know my smallest guy, I can figure out everything. Now that says 6. We're going to go now. Remember, I'm doing this horrible writing for your benefit because now I'll be able to save exactly what I write. Yes.
When you go on Blackboard to look at your responses, was it notes and you print them off?
Uh-huh. Yeah. I was like, wait, can I? Yes, you can. You can. You would just right click on the file, download it, or right click print, right, whatever. Yes. All right, question about example 4. All right. Our next objective, solving consecutive integer problems. What does consecutive mean?
One after another.
One after another, right? So 2, 3, 4, those are consecutive numbers. Make sense? So we're going to solve consecutive integer problems. Integer means that I'm not dealing with decimals or fractions, so that should make you pretty happy. Fine. All right, so one way of looking at it is that I have 3 consecutive numbers, agree? And I need them to equal 252. So if I have 252 and there are 3 numbers that need to equal it, let's figure out what would it be if I was on an even playing field, right? So if I had 252 divided by 3, that would make 84. So that tells me that 84 plus 84 plus 84 would equal 252. Okay? But I want consecutive numbers. So what it's asking is, if 84 is my middle, what would have to be surrounding 84 to make this happen? Exactly. So I can take 2 from this side and give it to this guy. Because that's the beauty of addition and subtraction. You're just changing hands. So my numbers would be 82 plus 84 plus 86. So you're just trying to recognize a pattern. Does that make sense? If you accept that math is just patterns, it'll make your life so much easier. Now, what they would want me to teach you is the whole formula. And I couldn't remember it, so I had to go find it. All right. So starting off, not thinking about it, but thinking about it in a formula sense, it's saying that, let me erase this really quick. That didn't work. It worked last time, but I think my finger was coming through. So starting off as an equation, it's saying that I have x, right? X is my first number, and I want an even number. Well, in order to get an even number, I got to make sure that I'm adding on to it. So every other number is going to be even. So my next number would have to be x plus 2. That's a plus sign. Go with it. And then my next number would have to be 2 more than that. So it would have to be x plus 4. And then I would add them all up. So I would have x plus x plus x, x plus x plus 2 plus x plus 4 equals 252. And that gives me 3x plus 6 equals 252. And then I would just solve it as normal. Now, what I wanted you guys to do is to think about it. How would you solve it just with the skills you have? Do you necessarily have to create an equation to make yourself able to solve the problem? No, because you already have the skills to recognize patterns. And I wanted you to take a chance and focus on those skills. This is the mathematical way of doing it. So I would subtract 6. That would give me 3x equals, is that 246? Then I would divide by 3. So you see, if you just trust in your own math process, how much work it saves you. If you just use your own logic. And that gives me 82. So I know that my smallest number has to be 82, which did we not decide that already?
Where are you writing?
I thought I was writing. Where I thought I was writing at was right there. So my smallest number would be 82. And then what's 82 plus 2? 84. And then what's 82 plus 4? 86. Didn't we figure that out just by recognizing a pattern?
Yeah.
Okay? If you cannot lead to this train of thought, do not be mad. Do what feels natural to you. And if it feels natural to start off with, I have 3 numbers. I'm going to divide this by 3 numbers. See what it would be. Then go that route. Don't force yourself into this. Does that make sense? I want you to do what feels natural. Okay? Questions? They're going to lead you to the same answer, but one is going to make you feel real good on the inside. One may make you a little angry. Okay? So go with what makes you feel good. All right. That's the end of section 2.4. We are now moving into section 2.5. Formulas. So do y'all remember that green paper I gave you and told you only write your name on? Okay. These formulas, I believe, should be on that green paper. From my understanding. So we're going to use formulas to solve problems. The formulas are, can y'all double check to make sure that all 5 of these are on your green paper for me? Remember the one I told you not to lose?
I lost.
Okay. Well, I was told that these should end up on your paper, so let's look. Charles P. Can afford enough fencing to enclose a rectangular garden with a perimeter of 140 feet. If the width of the garden is to be 30 feet, find the length. So what did I tell you? Anytime we talk about an object, what should I do? Draw that object, right? So go ahead and draw a rectangle. I wasn't smart on this one, and I did not insert my rectangle already, so. But I figured I could draw a decent rectangle. Okay, so here's my rectangular fence. And it says the width is to be 30 feet. Now, when you guys think width, I think this way. Do y'all think that? Like, I think how wide my hips are. I'm like, width, okay? Some people, it doesn't really matter which way you go and write it, but I write width like this. So if that is 30, then the other side also has to be 30, agreed? And I do not know my length, so I'm going to put an L. I don't know what it is. So I do not know my length. And we just said, what does perimeter mean? Anybody? Add up. There you go. I'm going to add up all my sides. Just like if I'm a mall cop, I walk the perimeter of the mall. That's what perimeter means. Okay. So I'm going to add up all of my sides. Now, remember, I don't know if y'all heard me say that I'm kind of a lazy mathematician. So I know that I have two 30s. So instead of writing 30 plus 30, I'm going to write 30 times 2. Did y'all see my L just magically disappear? I don't know where it went. There you go. I'll bring it back. Okay. How many L's do I have? 2. So again, I'm a lazy mathematician. So I'm going to write 2L. And I know that together my perimeter equals what? 140. Boom. I just made an equation. And now I just got to solve for L. So 30 times 2 is? Oh, I'm paused.
How'd you get 140?
It says it in the problem. Perimeter.
Okay, all right. Where did that come from? Okay.
Magic. So I have 60 plus 2L equals 140. And now I'm going to do what? Perfect. Subtract my 60. I can't. I promise I'm trying the hardest. Amazon's going to be my friend tonight. I know. And I get what? 80. And then I'm going to do what? So I get L equals what? 80 divided by 2, 40. So my L equals 40. And what are my units? Feet. And I'm done. Yeah, remember we talked about you got to be specific. Explain why you have that number. What does that number mean? It means my length is 40 feet. How do we feel? Is it that bad? How do we feel about perimeter? Fine, good, gravy. Moving on. Now, converting. Now, can y'all tell me if this one is on your formula chart? It should say. All right, so using our formula that we have for converting from Fahrenheit to Celsius, we have F equals 9/5 times C plus 32, right? Using that formula, could I figure out what 5 degrees Celsius is in Fahrenheit? Oh, okay. Could I figure out what 5 degrees is? Yeah, because I'm just plugging into the formula, right? It tells me my C. What is C? I don't know what I did. C equals 5. I'm not rid of them either. C equals 5. So I'm going to take that and plug it into my formula. So in order to find the Fahrenheit, F equals 9 divided by 5 times 5 plus 32. I would like these boxes to go away. Touch watching it. I'm gonna click. All right. So I have 9/5 times 5. So when I have 9/5 times 5, I'm going to write it down here in my little free space that I have, since I can't write it anywhere. So 9/5 times, and I'm going to make 5 into a fraction. So 5 over 1. Does anyone remember from any math class what happens when you have the same number in the numerator as you do in the denominator? They what? They equal 1, so they cancel out. So all I'm left with is 9. Yes. Yes, we're multiplying. But we shorthand multiply because if I have the same number in the numerator as I do in the denominator, I can do what? Eliminate. I would have written it in the other space, but the computer has decided that I'm not allowed to use that space right now. So.
So can we write that example on our green paper or just?
No, you can't write examples on your green paper. You try to do. Okay, so now instead of 9/5 times 5, I can now just write 9. And what is 9 plus 32? So 5 degrees Celsius is almost equivalent to 41 degrees Fahrenheit. I don't have enough room. You see, I do not have the option. Yes, I can't. What do you want? Yeah, I will make up another one. If you put F equals 41 degrees, that's fine. All right. It made everything go away, but we'll work from there. Okay, so we have my triangle, and we already discussed that my 3 sides were x, 2x, and x plus 3, right? Okay, so now we're going to find the perimeter. Well, perimeter is adding up all 3 sides. So I have x plus 2x plus x plus 3. And what does my perimeter equal? 102 feet.
What do we subtract the 30? Would that be a smart thing to do or not?
Why did my 0 come on my 30? Maybe because I didn't write it. Could you subtract your 30? Yeah. Before you simplify? Yep. So I have 4x plus 30 equals 102. I'm going to subtract the 30 anyway, so does it matter if I subtract it before I simplify or after I simplify? No. For you it does? Then yes. Keep doing what you're doing, girl. Keep doing it. So I'm going to subtract 30. What I do to one side, I do to the other. So I get 4x equals 72. And I'm going to divide by 4. I'm like coming down to the bottom. Can y'all still see it? Barely. Barely. What is it? And 72 divided by 4 is 18. So I know x equals 18. Can I find what 2x is? 2 times x is? Anybody? Everybody? Almost 36. And then 18 plus 30. Perfect. And so there are all 3 sides, and I forgot my units. We're measuring in feet. 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 And that would be my answer. I lost my So on your test, if you don't fit the units, you will lose like a point. So make sure you get in the habit of writing your units. Units, units, units. I don't know what you're talking about if you don't write them. Yes, your test is paper. All right. Solving for one variable is our last part of 2-5. Okay. So I call this our plan of attack. Notice how I have like fighting kind of ish words. So our plan of attack. Step 1, eliminate the fraction. Step 2, distribute to remove parentheses. Step 3, combine like terms. Step 4, move your constants and unwanted variables. Okay? And step 5 is isolate the variable and coefficient. Yes. Isolate it. Eliminate, distribute, combine, move, isolate. Those are our keywords that we should think as we are navigating through the next process. Are y'all still writing? All right, let's apply these kick butt terms. Not sure if that's class appropriate, but it just happened, so can't go back. And it's recorded, so can't go back. All right, so here we go. We have M in R, T equals M times N times R. And my goal is to get what variable by itself? What does it say? I want to get 4 N. So my goal is to get N by itself. So if I want to get N by itself, I'm going to move things away. So currently right now, every single thing is being what? It's M times N times R, right? Everything is being multiplied. So that means I'm going to do the opposite of multiplication. And what is the opposite of multiplication? Division. So I'm going to write it big. So T equals M N R. And my goal, I'm going to highlight who I want to isolate. I want to isolate the N. So everyone else needs to go away so that N can be a happy camper. Because I am multiplying M, I'm going to divide M. Because I am multiplying R, I'm going to divide R. What I do to one side, I'm going to do to the other side. These cancel out. And now N is alone. So once N is alone, what does it equal? That's all T over M R. So I didn't have any fractions to deal with. What else? I forgot my steps. I didn't have any fractions, so I didn't have to worry about that. I didn't have anything to distribute. Whew, good thing. I didn't need to simplify. And all I need to do was get all the terms that I didn't want away from the one that I did. Isolate, right? All I need to do was isolate my N. And N by itself. That is all this problem wants you to do. It doesn't want you to have any numbers. It doesn't want to do anything else. It just wants to make sure that you understand your inverse operation. If I'm currently multiplying and I want to cancel that out, I'm going to do what? Opposite of multiplying is dividing. If I'm currently subtracting, the opposite is going to be addition. Okay? It just wants to make sure that you know your inverse operations. So let's do we have one more example. So if I have A equals P times R times T, I'm going to pause and have you solve for T. So here, if I have A, it's back, equals P, R, T, and I want to get R by itself, and T by itself, T wants everyone to go away. If I am multiplying, opposite of multiplying each one of these terms is to divide. I forgot the P. There it is. So now I know that T all by itself leaves A over R times P. And that would be my answer.
Does it matter which way it is? Like if you did A over PR?
No, ma'am. Just like saying if I had 2 times 3, it doesn't change if I say 3 times 2. It's going to stay the same. All right, any questions? Let's see. I'll take it. I'll take it and run with it. All right, so that's going to close us out of the problems I was just talking about are called mixture problems. Mixture problems, the best way that I know how to teach your mixture problem is to create a table. When you create your own table, it helps you organize your thoughts of what's being told, and it lines up your information for you. So on a mixture problem, for example, the owner of a candy store is mixing candy worth $6 per pound with candy that's worth $8 per pound. So notice how I write my $6 candy, my $8 candy, right? She wants to obtain 144 pounds of candy worth $7.50. So I'm trying to mix these two together so that my new candy will cost how much? $7.50. Okay, so this is what my mixture result should be. How much of each type of candy should she use in the mixture? Okay, so I know that in total I have 144 pounds, right? $6 is going to be a certain amount, which is unknown, so that's my N. And then how much ever is left is going to be my $8 amount. Okay? Then from there, how much does each pound cost? Well, each pound here costs $6. Each pound here costs $8. And my resulting goal is my new one will cost how much? $7.50. Okay? So then I'm finding the value of the candy. When you set it up as a table, it automatically leads itself into that multiplication. So in order to find out my value of my candy, it's the number of pounds times the price, right? So it'll be 6 times N. Then I would do the next one. The number of pounds times the price, which is 8 times 144 minus N. And so here my result would be the number of pounds times my price per ounce, which would be 144.750. I strongly encourage the table because from the table, now I can set these equal to each other. Because I know that these two things added together has to equal that guy, right? So I know that 6N, pretend that's an N, times plus 144 minus N has to equal 144 times 750. The hardest part is setting it up. But if you create a table, the table helps you set up your equation. Okay? There are other ways of doing it, but the best way that I've seen and understand is utilizing the mixture table, because it leads itself to your ultimate goal of having this equation that you go through your 5 steps of solving. So simplify both sides. Then we will move our variables. Then we will move our constant. Then divide by our coefficient. Okay? Because once you have the equation, it's now all free game. Okay, so I just kind of want to emphasize that a little bit. I will be making a video before next class. This time the video part won't be on, so you shouldn't see my awkward face. But I just wanted to touch on that. If you start doing the homework for 2.6 and you get to a mixture problem, you're like, oh my gosh, this makes no sense. Okay, are there any questions by what I just said? All right, well, have a lovely evening.